Hello, everyone. Thank you for inviting me to talk about my favorite subject, lenticular 3D and lenticular art. I know I have 20 minutes, so what I did is I prepared a very short presentation, and then I also have some lenticulars I'd like to show at the end of that presentation. So with that, I'm going to share my screen and begin. And I'm assuming you can all see this presentation title slide. So my presentation, of course, is on 3D lenticular. As I told you, I'm Michael Brown. There are two Michael Browns, Michael 1.0 and Michael 2.0. Michael 1.0 had 18 years at Eastman Kodak Company, had degrees in photoelectronics, and worked in a variety of imaging capacities. Michael 2.0 started in 2005 when Kodak actually downsized and I was let go, and I decided to pursue my passion of art. And more specifically, I grew into becoming a lenticular printmaker, and I currently am a full-time artist. I sell lenticular art at outdoor shows around the country, through Cape Cod Gallery, and on the internet. I also moderate a Facebook group for lenticular enthusiasts. So enough about me. Let's get into 3D lenticular. It's a great way, another great way of sharing 3D content. I'm sure you all have the experience. You love three-dimensional imagery. You have pictures, you want to show them or share them with friends and family, and people have a hard time viewing them. 3D, as wonderful as it is, it's inconvenient. You typically need a stereoscope, glasses, have to learn to do the eye gymnastics of parallel free viewing or cross-eyed viewing. Well, you don't worry about that with lenticular. I can make a lenticular print, hand it to my 90-year-old mother, and she can look at it and see it in its glorious 3D. None of the other things you have to do with viewing a traditional stereo pairs. So 3D lenticular is also great for wall display. I'm sure you have some stereo pair images you especially treasure and would love to have lenticular prints made of those. Well, that's all possible these days. What I enjoy about lenticular art, or 3D lenticular, is that it's a physical, tangible piece of art. You can hold it in your hand. It can become a treasure in your family. In this age of Instagram and Facebook, we're so used to just swiping by, dozens of pictures a day and not really savoring them or cherishing them. Well, the lenticular, because of the tangible nature, is different. And I suppose you could say the same with a stereo card, how nice and collectible and physical those are. Now, lenticular is not a perfect medium. It has some limitations, one of which is that it's lower in resolution, the horizontal resolution, compared to traditional photographic processes. There's generally less depth in a lenticular print, so you don't have that tremendously deep view you can get through a stereoscope. The images are best viewed straight on, and as you transition off to the side, you'll typically see a little flash or reset as you move outside the defined viewing angle. And unfortunately, lenticular pictures are a little more difficult to make than other types of 3D imagery. So the magic is in the lenticular sheet. That's that plastic coating that covers lenticular print. It's actually an arrangement of what micro lenses, and for the purpose of 3D imagery, the micro lenses run vertically or up and down. Lenticular sheets can be divided into two broad categories: narrow angle sheets, which are typically used for three-dimensional imagery, and animation sheets, which are generally used for pictures that change as the viewer moves or as the print is rotated in the hand. You can also say lenticular sheets can be divided into two families: the very thin sheets, which are typically used on printing presses for DVD covers, bookmarks, rulers, baseball cards, things of that nature. And then there are thicker sheets, greater than a millimeter, 1 millimeter, 2 millimeter, 4 millimeter. Those are generally used for digital printing, for example, with inkjet printers. All things being equal, the thicker the sheet, the greater the 3D. All things being equal, the coarser the lenticular screen, meaning lower numbers of lenticles per inch, the greater the 3D effect. Now, what's exciting is for the past 20 years, it's been possible for you to print your own 3D lenticulars. In fact, I print mine right from a home studio. So 3D lenticular is a little different than stereo photography, where we normally take two pictures or a stereo pair, typically one view for the left eye, one view for the right eye. lenticular pictures use a frame series. They use more than two images. And the base between the first picture and the last picture, or the left eye's picture and the right eye's picture, is wider than a traditional stereoscopy. So generally, it's between 3 and 12x a stereo base, a total base. As I mentioned, the lenticular prints, or I should say 3D lenticulars, are both the print and the viewing device. The stereoscope is actually built into the print. So a very, very, very brief history of lenticular, kind of dumbed down by decades, right? Most of the breakthroughs occurred about 100 years ago, between 1900 and 1930. And a few gentlemen I have listed here are Lippmann, Ives the father, Frederick Ives the son, Herbert, Walter Hess, and Charles Quinault. And those gentlemen, and probably others who were working but aren't as well recognized, came up with the techniques that we utilize today. Lippmann came up with the idea of an autostereoscopic image, and he modeled his design on the lenses or eyes of an insect. And you probably have all heard of the technique called fly's eyes, where you have these microscopic lenses, and it gives you parallax from side to side, or up and down, or at angle. It's parallax in all dimension. These days, we think of light field imagery, light field displays. Well, you can say Lippmann was the father of light field. Just before Lippmann, though, there was Frederick Ives, and he came up with a technique called the parallax barrier. And it's actually an arrangement of black and clear lines that would be on the front surface of a glass plate, and on the rear surface would be the photographic emulsion. Now, amazingly enough, he was actually using 200 lines per inch, so it was very fine. And he would have the two images interlaced on the back side of that plate on film. And you could take this plate and hold it up to a window or a source of light, because it was a transparency type material. And then you would get it the right distance away from your face, and just the correct position, left, right, and then a three-dimensional image would appear. So it had a very defined viewing sweet spot. And of course, because half the front of the plate was coated with black lines, it's a rather dark image, and that's why you'd have to view it backlit. So Ives came up with the idea of the parallax stereogram. So instead of the fly's eyes, he used the parallax barrier. But then later, Hess came up with the idea of using a lenticular lens instead of the parallax barrier. So now the whole image, or the whole surface, was clear, so it had greater light transmission. And the final breakthrough was the realization that it's better to use more than two images. They went from a parallax stereogram to a parallax panoramagram, meaning there were more than two pictures. We move into the 40s. There was a photographer in France, Maurice Bonnet, and he's considered by many to be the person who had made the greatest lenticulars ever, including up into our modern times. Now, Bonnet will talk about a little more in detail later in the presentation. The 1950s was the age of Victor Anderson and Very View. He made the little winky pictures that would be in Cracker Jack or in cereal boxes, the I Like Ike campaign button that was a flasher. So he did both animated pictures and some 3D pictures at Very View. The 1960s ushers in the age of mass-produced lenticulars, baseball cards, postcards, exographs. They were finally able to make lenticulars, not with a photographic process, but with a commercially printed process.
Trying to bomb it again?
1980s is the Nimslo camera system, a mass market system that consumers could use to take a point and shoot camera, send the film off for processing, get their own lenticular pictures back. 1990s, the age of digital. Kodak had a group called Depth Imaging, later named Dynamic Imaging, that would make both 3D and animated pictures, again on film. The Kodak Dynamic Images, again, are considered some of the greatest lenticulars ever made. Much like Bonnet, Kodak and Bonnet, they both used film. Film is a very high resolution recording medium. It allows you to get a lot of frames and a lot of depth in your lenses. Now, late 1990s, a gentleman named Ken Conley started a business in his basement, a business called Microlens. Now, Ken had actually worked on the lenticular array for the Nimslo camera system. He started a business where he was engraving cylinders that would be used by plastic extruders to make lenticular sheets. And the start of that business was to make lenticular sheets for commercial printers. But as inkjet technology evolved, he realized he could make thicker sheets that could be used with inkjet printers, allowing individuals to make short-run lenticulars. So we reach the 2000s. All of a sudden, do-it-yourself 3D lenticulars are practical. There's commercial software, high-resolution inkjet printers, and lenticular sheets that are easily available. So taking just a little deeper dive into that history chart, I want to mention Bonnet again. On the upper right, you see one of his cameras, a scanning camera. That camera would arc around the track. Typically, there would be a subject about 6 feet or so in front of the camera, 2 meters in front of the camera. And as the camera moved, the imagery was optically interlaced onto a sheet of film in the rear of the camera. After that film was processed, a lenticular screen was bonded to it, and then you would get these terrific pictures. Now, those were on large format film, usually, but not always, on transparency material, but there are also reflective prints available. The bottom two pictures you see here are samples made with a Bonnet camera. These were actually owned by David Berder. He let me photograph his pictures on a visit I made with him, and they were done by Harvey Prever out in the Southern California area. In the 1950s, when 3D movies came out, they were making lobby display posters and other promotional items. So the 1980, the Nimslo lenticular, this was the consumer point and shoot. You can see this particular camera had 4 lenses on. They would call that quadrascopic. There were derivatives of that camera that would use 3 lenses, 4 lenses, 5 lenses. The most common clone would be the Nishika, but there are a few others. Typically, the user would expose color negative film. That film would be wet processed, and then the negatives were actually projected through the front side of a lenticular roll media. The imagery was interlaced that way. The back side of the print material was coated with a white titanium oxide backer, so it would be a reflective print, and that backer was porous, so the chemicals could actually migrate through that backer and develop the photographic print. It used a very fine lens screen array, 169 LPI. The bottom right picture is actually me holding one of David Berder's variations of the Nimslo. He made cameras we call Birdlos, and they were done by slicing together multiple Nimslo cameras. So he had some with 2 cameras providing 8 pictures. The one in my hand there is a 24 lens, so that would actually have been made from 6 individual cameras. So David Berder, my hat off to you. The man is a genius. Now, Kodak depth imaging, they started in 1994. It was really an internal sort of skunks work project that grew into a business. They would take digital files and actually encode them to film using LVT, or light valve technology film recorder, very high resolution, over 200 color full continuous tone pixels per inch. That's about 5 times the resolution we can get with inkjet printers. So just to rough it off, you get 5 times the quality. You have more frames of animation or greater depth. That's the advantage to using high resolution film. Now, the business ultimately did not succeed because lithographic printing cost less than photographic materials. That top right image you see, I have little pliers next to it just for scale. That's actually a 16 by 20 inch film transparency. That box stands in relief against the stone background. And not only do you see it in 3D, but as you walk by, that box rotates. So really just an incredible piece. So my personal experience, I started down this road in 2005, and in my mind, it was imagining I wanted to make something like a full color hologram, a picture you would hold in front of you, and it would look like a window to the world that you could just reach in and would have this tremendous depth. I never achieved that, but that was the goal. So I started with a Nimslo camera. I had purchased one in the 1980s. I thought it would be a good way to start. So I scanned 4 frames of film. I purchased some lens sheets from Microlens. I found free interlacing software on the internet, and I made my print. And it was a complete disaster. It was a dud. It just did not have the kind of depth that I was hoping to achieve. So I tried a digital camera, and I put it on a small slide bar. And this time I took 5 pictures. I thought 5 might be better than 4. Maybe that's the secret. And it wasn't much better. And summer was approaching. I lost interest. I thought, well, I'll explore this over the long winter nights. So it was probably a year and a half later when I found some new software on the internet, and there was a company called Home Illusion or Power Illusion, and they made this software, and it allowed you to actually, they had a kit. So you have the software, they'd give you a few lenses, and they had a small laminator with it. And the idea was you could make lenticulars at home. So I tried that, and somewhat successful. I found another company software, Humanize, and I was actually able to make a terrific 3D picture with the Humanize software. So I knew all of a sudden it was possible. There's ways of doing this. I just have to figure out how. And 15 years ago, there was not a lot of information available on the internet. There's still not a tremendous amount, but there's more. So I tried all sorts of experiments over the next 6 years. I would put multiple cameras on a tripod, fire them all in sync. I put wheels on my tripod and arced around my subject with the Monet camera. I took a subject, a model in this case, put it on a rotating turntable, and the camera was stationary, and she would move, and I'd get all these different angular positions. I put a camera on drone. I would track trains with a handheld camera. I would take pictures out of an airplane window. Anything I could do to generate a frame series that had different horizontal perspectives. And then other experiments, 2D to 3D conversion, 3D to 3D conversion. The idea that you could take one picture or a stereo pair, generate a grayscale depth map, and that depth map represents different distances from the camera, and then use software like Stereo Photo Maker or Triaxis Stereo Tracer to take the image and the depth map and generate a frame series for lenticular print. Now, if you were to visit my studio today and want to see me make a 3D picture, what I would probably do is set up 2 tripods like you see in this lower left picture with a slide bar on it, and I'd mount my Sony camera on there. I would basically just slide the camera from right to left, holding down the shutter button. I'd take a series of 70 photographs, and I would use a subset of those photographs to make my finished lenticular print. I have experimented and continue to experiment with multiple cameras fired in synchronization. The center picture shows my current system has 4 Sony RX0 Mark II cameras on it. You can see they're all jammed together, but if I want a wider stereo base, I can separate those cameras, putting more distance between the individual cameras, and using computer software where I can actually generate in between frames from those 4 views. So I can take those 4 cameras and I can actually make 100 frames from 4 if I so desire. And then as far as printing out my pictures, I use an Epson inkjet printer. I have a desktop one and I have a wide format one. And I print onto a white polyester film. The basic workflow is to come up with my frame series and then take my lenticular sheet. And when you purchase these lenticular sheets, you first test them. When I make small lenticular prints, I'm currently using a 60 LPI or 60 lenticule per inch sheet. But before I use that sheet, I print out what's called a pitch test target. You can see the center picture. The left view is the target without a lens on. The right center shows the lenticular sheet bonded to that pitch target. That pitch target basically has alternating white and black stripes of different frequencies. It turns out my 60 LPI lens tests out to be 60.1 LPI at a viewing distance of 18 inches. So I use that value in the software, and that what it encodes or interlaces the picture. The top right view shows a close-up of an interlace of this model's lips. You can see these vertical bands. Those represent the 1/60th of an inch width of the lenticular lenslet. And then within that 1/60th, there are vertical columns of pixels, which represent the data from all the individual frames. So that lenticular print, when bonded to a lenticular screen, will refract all those frames out into the viewing angle of the lens. So I take the interlaced print, print it on the inkjet printer, and then I bond that to the lens using an optically clear, pressure-sensitive adhesive. And when the lens and the print goes through those rollers, it bonds them permanently together. I then trim the print, sign it, put the edition number on, do the matting, framing, and so forth. And then it's ready for someone to enjoy it in their home. Now, lenticular is a very deep field. There's a lot of little technical details, and I can't present those details in such a short presentation. But what I've done is I've recorded a 1-hour presentation. You can see it here, titled 3D Lenticular Tools and Techniques. That's up on my YouTube channel. So you go to YouTube/C for channel /Michael Brown Artist. You'll see that as well as a variety of my other videos. I often live stream as I'm working in the studio, and I have those live streams archived. So if you want to see how I'm working, if you join me during a live stream, you can actually ask questions and I can answer them. That's a lot of fun for me. I also have a Facebook group, which I mentioned before. It's titled Lenticular Art, Printing, and 3D Photography. You're all welcome to join. We have a lot of people that have never printed a lenticular and just have questions, and myself and a variety of people are happy to answer those. So I have a website, michaelbrown.com, Facebook, Optical Art, Instagram, Art of MJB, and YouTube, as I've already mentioned. And I post to all of those sites constantly with sample lenticulars or what I'm up to. So with that, that's actually the end of the PowerPoint presentation. I would like to show you just a few lenticulars. Let me stop presenting my screen. Okay, I'm hoping I'm back. I just see a lot of faces there. Can you all see me? Awesome. So to begin with, this is a small lenticular. This measures approximately 30 by 30 centimeters, 12 by 12 inches. It's a narrow angle viewing lens. I'm just going to wiggle this side to side, and I think you can get a sense of the parallax in there. So of course, video, the camera is one-eyed. You won't see the depth, but you can see some of the effect from that. So,
you guys can pin his screen if you need to see it bigger.
Oh, thank you for that suggestion. So this is what I call the ultimate selfie. It's kind of life size behind that. This is actually, it started with 300 pictures. It was done in an orbital dolly in the living room. So this has both the 3D effect and the motion. So as you walk by, I wink at you. And so amazingly, I made this for fun, but people buy this. I'm hanging in guest bathrooms across America. You go to someone's home, you'll be in their bathroom, and all of a sudden there's this crazy guy on the wall winking at you. What's that all about? So I like to show this example as a good example of parallax. So here I'm having it straight onto the camera, and I'm going to rotate it slightly. You can see the side view of that film cassette with a little spool coming out. Now we're centered again. I'm going to come over here, and now you can see the other side of that cassette, right? So this was done by putting the box of film and the cassette on a turntable. The camera was stationary, but I captured all those views, and those all show up in the lenticular print. So this is a little bigger. This is 16 by 16 inches, 40 by 40 centimeters. Now you knew about Bonet, I told you, with the swinging camera. So this is a piece I did a few years ago, and I actually used the orbital dolly. So the tripod had wheels on it. Those wheels could be set at precise angles, and that would allow me to arc around the subject. So this particular piece, you can see we're arcing around. So this has, you know, that kind of beautiful depth. And what I like about the arcing is the perspective of the room changes. For example, on the back wall here, you see this little table with a statuette on it. We arc over this way, that table actually gets bigger. So it's just kind of a neat effect. I personally prefer the arcing technique as opposed to just a linear rail, because I like that change in perspective. I think it makes for a much more dynamic image, but it's much more difficult to do in practice. Similar thing here. So here, I'll just do this. You see a woman by the piano, right? She's standing up, she's smoking, but we move this over. Oh, well, there's a guy back there playing on the piano. Okay, so these are sort of like windows, and as you change your position relative to the print, you can actually see around. You have sort of that look around effect. And that's what I like about actual 3D photography. A lot of people now will take standard imagery, 2D or 3D, and make depth maps, but a depth map almost gives you like an embossed view. You can't really look around an object with that. So I prefer the actual photography. Just a couple more. This one I call riding the rails. So you have the dynamic motion, and it's also 3D. Now, if you look, you can see that railroad track is curved, and that's the secret to the 3D. As the train was moving, I waited till we got to that curved section, because then physically I'm moving horizontally. Okay, and that's what's giving the 3D effect to that one. So it's deep. It has both the depth and the motion. And then one last one. This is an example of a drone picture. So the drone was up in the air. This is a little more narrow angle lens, so I can't swing it as much, but you have depth. So the drone was flying. I had a buddy, and he just flew it horizontally past the lighthouse. I was able to get my series of frames. Now that works good as long as nothing's moving. It works stationary. Well, the lighthouse, of course, was perfectly stationary. But if you look close at that print, there were some people walking on the sidewalk, and there was a little flag blowing. And as you rotate and walk by, you'll actually see those people move. So with that, that's the end of my presentation. I have no idea if I've maintained myself to the 20 minutes, but if there's any questions, I'd be happy to answer them.
That's perfectly okay. Thank you so much, Michael. I am blown away by that train track.
Oh, thank you.
That's amazing. And I do, and the one with the person that appears into the picture, that is just, yeah, mind blown right now. Yeah, we do have some time. I want to give at least 2 or 3 minutes for questions. So please, if you guys have questions.
I've got a question for Michael 1.0.
Oh, yeah.
How much do you hate George Fisher? And did you ever encounter a Roy Ference or my friend John Carson when working in the imaging department at Eastman Kodak Company?
Well, first of all, I did not meet your two friends. I do remember George Fisher. George Fisher, brief history, came in from Motorola. He was an outsider from Kodak. The idea was to turn Kodak around. Motorola, very into electronics. Kodak knew it had to move into electronics. That was the mid-1990s. I actually liked a lot of what George Fisher brought, but you just couldn't turn that company around, unfortunately. I mean, they had said, and I believe it, there would be more profit in a single roll of film than in selling a $200 digital point-and-shoot camera. You know, by the time you factor R&D and labor and everything else, and so, you know, Kodak just had a lot of excess money in the film days, and not so much later on.
Great, thank you for that question, Ian. We have another question, and so we'll kind of give another couple of minutes. David has a question. Oh, you're on mute. Oh, still can't hear you. And you're not muted.
I suppose you can put it in the chat.
Yeah, maybe type it into the chat. Not sure what's going on there. I know we heard you earlier. So let me just check the chat to see while he's doing that if there are any other questions, because I would like to get to Pascal's presentation, and then we can take all questions then, more questions at the end. But let's get David's question. And there are lots of other comments, Michael. Oh, how do you keep the print aligned with the lenticular sheet in the laminating process?
Wow, very carefully, right? So what I do is I take my print out of the printer and I tape it to a light box. And then I take the lenticular sheet, I cut off 1 centimeter of the release liner from the back, so there's sort of a tacky area exposed. I cover the print with a silicone piece of paper that nothing will stick to, and then I lay the lenticular sheet on top of that print. There's a registration border around all of the imagery. I can move that. First thing I want to do is get the lenticulars parallel to the interlace lines, and then I have to move that left and right centering. I use the registration grid for that as well. After I have it rough aligned, I use a loop which magnifies the views, and I can see things at 8x, so I critically align that. When it's all in position, I tack the top of the lens to the print. That will hold it in place. I carry it over to the laminator and then bond it together. So it's something that requires practice. The first 10,000 are the hardest. After that, it's pretty easy.
And I'll give one more because this was typed in really early on. If it's a short answer, how would one load a custom 24-frame NIMSLO in a darkroom/dark bag? So curious.
That would be a question for David Berger. I've never shot personally with the 24 lens NIMSLO, but I can certainly see the thing. If you had a 24 images, that would take up 12 frames of 35 millimeter film equivalent, because it basically was making 4 half-frame exposures. So I suppose it would actually be possible to pull out enough wasted film to use as a leader, close the back, and maybe get either 1 or 2 exposures. Oh, David Starkman's giving me confirmation. Thank you. That was all speculation.
All right, great. Thank you so much, Michael, for that was, yeah, just the history and for showing your art. And let's.
Kita, I see one more question in the chat that we missed. There used to be a stereo photography club for Kodak employees only in Rochester, New York. Wonder if David was a member of the now defunct Genesee Valley Stereo Club.
David, who would be the first question? I should indicate, when I worked for Kodak, I was in the field. I was in Dallas and Chicago. So I would go to Rochester for training, but I didn't know a lot of Rochester personnel outside of my business unit.
I see that he corrected it. He actually meant Michael. If
yes.
Michael was a member of the now defunct.
I was not a member.
Okay.
So. All right. I thank you. I will mute myself and I'll be available at the end.
All right.